The Integrated Design Lab. What are we in spring? Spring lecture series. It is a beautiful spring day here in Boise. My name's Kevin Vanden Mellenberg. I'm director of the lab here for the University of Idaho. Thanks to our funders, as always, Better Bricks, Idaho Power, Northwestern Energy, and Avista. The lectures are now broadcast live up in the Spokane lab, which is exciting. So welcome to Spokane. For anybody viewing online, please don't hesitate to interrupt us with questions. There's about a 2-minute time delay, so we'll do our best to get your question in either real time if it still is relevant, or as shortly thereafter as possible. So email gunnerg at uidaho.edu, and that should also be on your screen in case you forget. That's Gunner, G-U-N-N-A-R-G at uidaho.edu. For folks online, we are doing AIA CEUs. There'll be a test. Unfortunately, since you're not in the room, we have to do a test. And we'll be sending that out to anybody who's logged in. So look for that very shortly. And for folks in the room, just make sure you sign in. Put your AIA number down if you need CEUs that way. And engineers, there should be some certificates available by the end of the lecture for self-reporting. Got to go through my list and make sure I handle everything here. Of announcements and evaluations. Okay, so a little bit new for folks who weren't at the very first lecture. This year we are doing evaluation forms. It's a very simple 9-item, I think, 11-item evaluation. We'll hand them around before you all leave so that we can continue to improve the quality of our lecture series for you. This is the second in the series of lectures in the spring series. We have April 15th, our own Ari Junedi is presenting on right-sizing rooftop units, which is, of course, a really tricky engineering problem, and that was results of some of the work that Idaho Power funded last year for the lab. And then on April 22nd, we've got Lou Capozzi coming from the Genzyme building all the way from Boston, which is pretty exciting. It's a very high-performance building built in, I think, 2005 or that time frame. A little earlier, 2003, with Danish architects out of Germany, I believe. On April 29th, the last lecture is Heather Burpee coming from the University of Washington to talk about high-performance hospitals and the update to their research on that topic. Other announcements very quickly, and then I'll turn it over to our star-studded cast for the evening. If I can get all my papers in order. Coming right up, we've got Thomas Auer from Transolar, managing partner of Transolar in Stuttgart, coming to talk on, what is the title here? I don't have the title. High cost? No, not high cost. High comfort, low impact. And we're hosting commissioning webcast on, Brad, what's the date? April 21st from 10:30 to 3 o'clock here at the lab. It's just going to be a webcast. We'll host it up, have a little discussion afterwards. And then finally, our regular BSUG will be coming up very shortly, if not the second Wednesday of this month. We're working on an outside speaker, so it may be a little bit different date, but coming very soon. It already was the second Wednesday of the month, wasn't it? Any rate, we're ready to go for tonight. We have a great team from CTA Architects and Star Construction, is that right?
Corporation.
Star Corporation, thank you. As well as a representative from the College of Southern Idaho, a client representative. So it's a very unique opportunity to get a diverse perspective about the integrated design process from early design stages through construction and occupancy, and how the team dynamic works. And besides all of those interesting lessons learned, it's a really excellent project to boot. So we'll get to see some cool strategies and see how it was all put together. So I'm really excited. Thank you all for coming. Because there's 5 of you, I'll let you introduce yourself. I didn't get enough of a bio on each of you to do a good job. So please just run down the line and say hello.
Yeah, I'm Jason Butler. I'm the project architect on the project and with CTA.
And I'm Mark Sugden. I'm the instructional dean at the College of Southern Idaho.
And I'm Ken Butler, CTA electrical engineer for the project.
My name's Michael Arrington. I'm the president of Star Corporation. We were the design build contractor for this project.
And Ken Tewksbury, I was the mechanical engineer.
Take it away.
All right.
Thanks for coming.
Sure appreciate it, Kevin, and thanks to you in the lab for inviting us. We're pleased to present this exciting project, recently completed Health Sciences Building at the College of Southern Idaho in Twin Falls. As Kevin mentioned, we wanted to seize the opportunity here not only to display some of our internal teams dynamics with an integrated AE firm, but also have the opportunity to bring Dr. Sudkin down and Michael Arrington and show the dynamic between the owner, and as Michael mentioned, it was a design build delivery through the state of Idaho's Department of Public Works, so a bit unique in that fashion. I guess just on the screen behind us here is a bit of a hypothesis statement. We've all seen and familiar with the traditional design methodology, schematic on into design development and whatnot. Hopefully what we want to capture here a bit is to show how we push that envelope a little bit, move that decision-making process earlier in the process, given the fact we've got a very savvy client that owns and operates a number of buildings in a college setting. Really moving towards the red verbiage on the screen and truly integrated process. So. And again, as we mentioned, design build, we did have the benefit of a design build team that we've delivered projects for the College of Southern Idaho in virtually the same contractual relationships in the past. And as we mentioned, an owner that at the first onset meeting had, here's our criteria, here's how to build on the College of Southern Idaho, here's what we'd like to see in the building and expect in the building. So truly, I guess getting those ducks in a row from the get-go. We're all generally familiar, I would assume, in the audience with the AIA's delivery curve, ultimate curve to reach that early decision-making, call it the design development or detailed design kind of phase, and we'd like to share some of the techniques we employed along the way through this project to shift from a traditional, the red curve, to that early decision-making, kind of looking behind me here to catch the mouse, to that early decision-making purple curve. And again, as I mentioned, Star Corp from the very onset, the dialogue at the early development of the project was about making those decisions early to basically capture any decision-making process early to keep that ability to impact costs sooner in the project rather than later, where they get much more costly. Our project site is on the College of Southern Idaho. Correct me if I'm wrong, Dr. Sudkin, but about 4,800 full-time students, part-time students, 8,400.
Yeah, that's about right. Yeah.
Our project site, however, was not on the developed southern side of the campus. Our building site was actually a bean field that was just north of North College Road. Those of you familiar with Twin Falls, the Snake River Canyon and the Prime Bridge into Twin Falls is just further north of our site. We did have the benefit, and the college has the benefit, of a geothermal source on campus in a bit more detail a little bit later on with Ken. We did have the benefit of utilizing the waste stream, or a second life cycle, coming off the Desert and Canyon building to our site. And again, a recently completed project, again, our knowledge of the client and the college, design build relationship on the recently completed 4 or 5 years ago, Michael, on the CSI's rec center. So really had an idealized situation here, everybody, of the right ingredients and the right place, right time with this project. So quite a benefit. The project started out late August of 2007, much like any would, with a pre-design, fact-finding, gathering, extraction of a problem statement, if you will. I guess the greatest thing there is the engineers engaged in that planning process. Many of the designers, some of them in the audience here, Zach and Christine and Brian, took a little bit different route. They got an understanding of the site and engaged the lab very early on, got an understanding of what the solar orientation is doing with the site, the winds. Being in Twin Falls, and you saw that quite an open bean field, we don't have the benefit of other buildings and other structures to protect it. But the designers went that route and left it up to the architects and some of the senior engineering team to really extract the problem statement out of the client. So we hit the ground after the pre-design effort, really kind of with the criteria in place, playing off that integrated language a bit, with the spaces understood, the general relationships established, and this was what we had in our hands when the designers stepped in and took charge and began leading the project from there. 1st of November, however, we held an eco-charrette. The college made a conscious decision to pursue the project as lead. It was not part of DPW's original program, and it was really the biology background of Dr. Sudkin and many of his biology faculty that were involved with the project at the time that really pressured some of their administration towards that way. So you can imagine there was some dynamic dialogue along the way. So I guess we did elect me as the project manager to have a peer of mine, Scott Roberts, be the lead project manager for the lead process and really be responsible for that documentation and who to push on and when and where. So this is Scott leading the eco-charrette. And again, we had the benefit, a gentleman right back there at the back of the rooms, the president of the college, clear through the full design team, the contractors at this point, facilities gentlemen, and ultimately the end users of the building at the eco-charrette and contributing that evening. It was a bit of an accelerated process, maybe not idealized. We would have maybe liked to spend a bit more time, but it was accomplished in about 2.5 or 3 hours. And the lead scorecard at that point just had a few credits on here. Wanted to highlight. This is the actual scorecard that we came out of the eco-charrette with. The water efficiency at that point, we were identifying 1 yes credit and 3 no credit, or 3 question marks. We've got these playing back a little bit more. We have the benefit of capturing those 3 question marks to the yes column a bit later. Other credits to highlight is the optimal energy performance, and we left the eco-charrette at a modest 28%. And again, a little bit later in the presentation, we ended up quite a bit deeper on the project than this. Again, just highlighting a couple of others. Construction waste management, and again, having the design-build relationship and STAR there from the get-go. Initial concern of the resource capability of a construction waste stream in Twin Falls and just where those materials might go, but wanted to really bring everyone's attention to the 75% credit that will show later that was ultimately satisfied and captured, moved from a no column into the yes, and then the recycled content and the specification of materials. So we left the eco-charrette at, I think, feeling generally pretty good with the ability to convince the administration to pursue lead and get it written into the contract, I believe, at this point, Michael?
Yeah, at this point, we accepted a change order from DPW to that contractually obligated us to deliver a LEED certified building.
Yeah. So again, leaving the eco-charrette at a modest 31 points, and again, everyone feeling pretty good at that point. So, moving a little deeper into schematic design, I want to point out that the college is quite good at knowing who to engage in meetings and when and where. The meeting size, the participants in the meeting, they know when to have the decision makers there, when to open it up to the end users. You'll notice in this slide a bit of a transition that the designers are leading the team. Zach Lester, that's here in the audience, stepping up and leading those meetings all along the process here. We also How's it going? Had the benefit, with the design-build relationship that STAR really enabled our architects and ourselves to do our jobs as designers and engineers early in the process and perform like we would traditionally, and not have that, forgive me if I'm giving you a good thing over there, the heavy contractor hand coming at us all the time. And
We have them, just didn't use them at that point. No, that's where the architectural and engineering side of our team shines. We understand each other's strengths, and we have no business leading at that point. That's what CTA was there for.
Again, greater understanding, and I believe this is about the point that the lab that we're sitting in right now, the Integrated Design Lab, was engaged. And again, building form, building shape being examined by the designers, building orientation with the exposure of not only solar and wind was of paramount importance along the development of the project. These were some of the early concepts, schemes A, B, and C that came out. And it's really a 360 building, given its nature on campus. If you're familiar with the campus, they've got an outside loop drive that is really the back sides of the buildings, but you see them first as you're approaching the campus. The interior courtyard on kind of that figure 8 scenario as you're a pedestrian inside the campus core. So. Very much a 360 building that the designers were dealing with, and ultimately Scheme A, you'll recognize that form that was further developed. This was an interesting slide here. Now we're going to spend a few minutes. We began a bit of a different meeting format, at least within our context, in our office. We called it the Scrum Process, a rugby term, kind of swiped from software design, architecture design, engineering practice. Software industry's been utilizing it since the early 2000s. Really just a dynamic meeting process. Rather than having the weekly 2-hour team meeting, we went to a 15-minute daily team meeting format that answered 3 fundamental questions. What do you need? When do you need it? How can I, what are your roadblocks, basically? It was dynamic. It really revolutionized the way we're dialoguing with the architects, the engineers, the civil, the landscape within our offices, and to the point where we're sitting in an integrated fashion now. Architects aren't sitting in their little groups. They're sitting next to their engineers and so on. And I think it was a little bit rough on the older gentlemen down here for a little bit. It changed kind of their traditional methodology and their delivery. So, not much to share. They're still quiet, huh? It really continues to the past couple of years on many of our larger significant projects, and they come every day and love it. Gosh, they're quiet. Further refinement that the designers were doing with the lab, again, just really capturing the building form. We're starting to see the building take its shape and break apart for solar orientation and the daylighting studies that were being done. Just the beginning of physical models and utilizing the light box here in the lab quite heavily along the way. And again, greater refinement. This is actually one of a later sketch, but significant consideration, and you'll see it in the completed photos here in a bit, but significant consideration given by the designers and the really the entire team, structural, mechanical, electrical, to the orientation of the skylights, the light monitor, the shading devices on both north and south elevations. Again, early energy modeling going on, schematic design.
This is the eQuest model that we started at this time. You can see that there's not a lot of detail, but one of the big things that we were taking a look at here was the glass. was important that we, since we were going for daylighting, we wanted to make sure that we weren't also increasing loads. And I remember we had a pretty good meeting down here where we really had some really good give and take about just exactly what can we do as far as glass and what can we do to minimize the effect that we were going to get with the heat gain of that glass. And as a matter of fact, the ultimate project ended up with 5 different glass types. And I think if you look at the building, you really can't tell that. But what we really tried to do is optimize the glass for the exposure. And on those areas where we really had some concern, we were able to cut down that heat gain significantly. Worked out well. This is our original consumption that we were looking at. One of the things that we do have, as far as power sources, we are all electric. They don't even have gas on the campus. So that's one of the things that we were looking at quite extensively, was the electrical consumption.
I guess at this point, we're transitioning into design development or more of a detailed design mentality with the integrated model. You see, this is actually Glenn Arrington, Michael's father, a bit more of a heightened role of the contractor at this point, but they were at every meeting along the way. And again, this was just before the meeting began. Again, the college controlling that size of the meeting, and but this was a final or a early design development presentation to the ultimate end users. The modeling, actual presentation type modeling at that point, and again, we're early design development at this stage. Physical modeling going on, a bit more detailing with the lab at that point, really taking advantage of that valuable resource that we all have here. And again, this is a cross-section of lighting levels, beginning to study what the form of the classrooms. This is a typical classroom space on the north elevation. We do have the benefit of taking a look at the ultimate roof monitor that was placed and the modeled light levels. And again, the size of the meeting getting controlled when you get down to the sensitive nature of interior finishes and exterior finishes, and there were actual board members at this presentation that afternoon that had a role in the selection of the materials. And again, tremendous benefit to have the design build methodology and having ability to build whatever we needed to for mock-ups along the way. And just having those decisions behind us very early on, keeping in mind that purple curve that we showed earlier. Ken, a little bit more model refinement and design development?
A little bit more refinement. Started showing some of the shading devices that we wanted to employ, and looked at some of that by this time. And Tim Johnson, who's in the audience here, was really did all of our modeling, and did a great job with ARI, which was an extremely good resource for us because we did have a fairly complex situation. One of the things that we decided that we wanted to use on this was the wastewater from the site, from the geothermal site. So we got 85-degree water from the site, and obviously we had to templify that, make it a little bit warmer before we could use it. So we do have a water-to-water heat pump system that we're using in this building, so that's all of that was starting to be, at this point, looked at to see just exactly how we could maximize those resources and what we could do to cut the energy use down.
Again, moving through the completion of design development or that detailed design, this was the actual presentation modeling that was done at that point. Virtually looks like this today.
I was going to say, I think it's amazing that this is done with a computer, because if you had a camera right there, that's just what it looks like. It's very accurate.
So really the benefit of those material selections being completed, that daylighting study and those early design decisions by really all three parties really behind us. again, moving into construction documents, this was the model that was presented at that point at the final design development, and this is largely the building that exists today from a modeling standpoint, or as a model. So we had the benefit of doing construction documents during construction documents and not having to go through material selections and those decisions. So.
Just the final shows a few more of the fins, a little bit more refinement of the glass. I think at this point we did change a little bit of the glass around just to really make sure that we were trying to maximize the energy use on the building. And this does show what we were doing with the ASHRAE 90 Appendix G, which we did use as a baseline. This just the second column just shows that we did comply with the baseline model and then our proposed model and what we were looking at for trying to get some more energy compensation there. And this just shows the breakdown that we had at that point for the end use of the building. What we anticipated at that point for monthly bills. And this shows some interesting aspects. I guess the ones that really jump out are the space heat. Obviously, the savings there is because of the geothermal resource that we have versus the baseline. And the other one I think that really jumps out is the internal lighting. Ken did a great job of really cutting down on the internal light, which definitely helps us with the cooling. From the heating standpoint, we're actually noticing it, and and you'll see a little bit of that. We're actually having to create a little extra heat than what the model said that we should have to. Part of that is also because the building isn't fully occupied, but definitely the internal loads on the building were cut tremendously. So just a little bit more of that. I guess this is actually where we are right now. And you can actually see where the heat pumps are not performing. These are not in the same scale, so we're not quite. But the wet side mechanical, and that's partially due because we're still doing some setup and a few things. But what this is we've actually have the college sending us their information monthly. And this shows March, so we're almost right up to date. Tim gets that information and actually puts it on the computer. He first of all created what we anticipate that the energy use should be. And you can see that we're very close on the total energy use. Where we're really seeing that savings once again is in the actual internal use. And then the bottom ones show that we're pretty good on what we call the dry mechanical room, which is the air handling units. Maybe not quite so good on the wet side, but we'll be getting that dialed in as time goes on.
So construction, it's not going to play. Oh, we had a cool little thing pulled together here. It's not going to play. Oh. Anyway, that was going to build the building for us. Construction began summer of 07, July of 07, and ran through end of December of 2009. I think your faculty moved in.
We finished up the fall semester in late December, started moving January 4th, and we're ready for business on January 19th. That was a huge accomplishment, a big chore, but we got moved in time. So we moved in over Christmas break, and we're up and running now.
Let's see if I can get it to advance. A little bit about the building now. Orientation's sake, and Mark kind of understated the move-in effort there. Being a health sciences building, healthcare training facility, the lighting, the sim people, the dental chairs and equipment that make up this building was quite an effort, and it really did take place in that kind of time period that Mark described. So it wasn't simply faculty, books and binders and that sort of thing. So the ground floor, and again we've got some photos here at the end, but the building's oriented largely or east-west. It's got a long southern exposure, easily to control. The darkest, the planning and the designers located the darker labs, the rad tech, the dental hygiene, and their various dark rooms and lab support space associated with those. On the actually on the south side of the first floor, the darkest space, that northern exposure really captured even light. But anyway, the darker space use is programmed out and located on the first floor, surgical tech and OR simulations. The project does have 3 large lecture halls, 2 90-person and a 70-person, with the ability to expand and pick up additional lecture hall space to the north. General classroom spaces were all uniform, and again, this is a 1-story element as you move down from the main entry down the floor plan to the west. Faculty office groupings or pods, really engaging encouraging the faculty to kind of cross-pollinate their disciplines and utilize like they're going to, and utilize themselves like their students will in a healthcare setting one day. Second floor, this is a 1-story, and again, the light monitor catching the general classroom space, but very repetitive classroom space upstairs. The nursing labs and simulation labs on kind of this interior street, we'll see photos of here in a bit. Computer testing is a significant part of the criteria and the evaluation process for the nursing students. It's a significant part in the building. And some of the nicer real estate location by the designers. I wanted to mention to everyone, I think much of the group here we do have handouts with a bit more detail with each of these bullet points, but we'll just spend a few moments on each of these slides, and then we do have a disc of the PDFs that I think Kevin and Gunnar will get available to everyone that's Spokane or elsewhere. So I think, Ken, just a bit of systems descriptions?
Yeah. Once again, we are using heat pumps with the used geothermal source, so that's a good deal. One of the other things that we did is used a dedicated outside air system on this building. You saw the lecture halls; those areas have a great deal of fresh air that's required. 90 people with 15 CFM per person, that is the requirement for the amount of air that we need to supply to those spaces, is based upon the ventilation rate. So we put the dedicated outside air systems in so that we could just put the air in the areas that we needed to, and didn't necessarily have to depend on our cooling system to actually provide that source. Otherwise, we would have been, by code, having to go to 100% outside air whenever those lecture halls were occupied in order to make sure that we maintain that ventilation rate. So we thought that the dedicated outside air system, it really is a good way of being able to take care of that situation. Use of the renewable energy. One of the things that Ken probably wants to explain that, we did have at one time some PV on it, but that didn't quite materialize yet, right?
We've still got the provisions designed into the facility to accommodate up to 25 kW of photovoltaic productions. And we're aggressively seeking grant programs to get that funded and installed on the building.
College is still highly desirous to pursue it, yeah.
One of the other things that we do is we actually integrated with the electrical to do occupancy sensors, so that we do a lot of our mechanical setup on the systems with those same occupancy sensors. We also have CO2 sensors in all major areas that allow us to control that dedicated outside air system based on the CO2 in the spaces. And another thing that Ken's got, explain your turn-off system.
Well, in this day and age with energy codes, we're using occupancy sensors. Some people prefer to call them vacancy sensors. We use the occupancy sensor terminology to control lights. Basically, in this building, the enable, disable function of the lighting is based on occupancy. So a person walks into the space, it senses it's there, brings the lights on, and then based on daylight contribution, we're ramping lights up and down to a predetermined level to maintain a predetermined level of light level. But one of the things that we did early on, we had seen some research that showed that there is perhaps as much energy wasted with plug loads being left on, and that we took it to the college and discussed it with them and said, we can control those plug loads as easily as we can control the lighting loads. So in this building, in the office built areas, typically you'll have an outlet on each of the 4 walls. In these there are 5. One wall has an uncontrolled outlet for computer functions, and the other 4 outlets in the room are also controlled from the occupancy sensors. So we had a interesting little training curve there when coffee warmers and coffee pots and a few other things started timing off when the space went unoccupied. But I understand from Dr. Sugden that the faculty and staff are retraining quite well to that.
Did you get a few calls initially or questions?
I've had some calls.
Can we ask questions at this time?
Oh, you bet. Yeah.
On dedicated air systems, this functions both in winter and summer, right?
Yes, it does.
So what kind of discussion did you have between the cooling and heating loads and the fresh air loads? How did you resolve those? It's extraordinarily hot outside and need lots of fresh air, so turn that system on. How do you balance those conflicting needs?
Sure. Okay. One of the things that our other system,
Ken,
our
I
second
think,
system.
I think if we can restate the question for the remote
Okay,
viewers.
I think the question is how, if we just have a dedicated outside air system, how are you using a use of an economizer during the periods of time when an economizer is beneficial? Is that the question?
That's part of the question, right? You have conflicting needs, you have fresh air needs, and you have comfort needs.
Right. We have 2 systems that kind of parallel each other throughout the building. We have a variable volume cooling only system, and then we have the dedicated outside air system, and then they combine together in the rooms. And the variable volume system also has full economizer capability, so whenever the outside air temperatures are suitable, that we can use 100% outside air like probably today, then they will use that economizer capability. And at that point, the CO2 sensors, of course, are going to be satisfied by the main air handling system, and the dedicated outside air system goes down. It just goes back on the boxes. We actually have boxes on the dedicated outside air system that control the amount of air that go to each space. That system regulates down, and then the fans go to a loping position, if you will, and so that we don't have to use that dedicated outside air. It actually can shut off if it goes clear down to the point where nothing requires the dedicated outside air system. And we are noticing that in periods like today, or when it is around the 55-degree range, we are able to use the main air handling unit and turn the outside air system down quite a bit. Maintaining right now maximums of 550 parts per million, somewhere in that magnitude. So, but during extremely cold and extremely hot weather, the VAV system, the variable air volume system, will go clear shut on the fresh air, and all the fresh air will be provided by the dedicated outside air system. So on the 2 ends is where it's going to really shine.
Ken, anything to highlight on the fan wall of the air handling units?
Well, just that seemed to be fairly successful. We are using fan wall technology, which is a large array of fans, allows us to really shut down fans that aren't in use. And also the mechanical room, I don't know if you noticed where our main air handling room is, but it's right over the top of the lecture halls, which was a concern when we first started. Didn't really do anything real special, and we were able to control that vibration and sound that goes down there. I virtually guess that you can't hear them running at all from the lecture hall, the units that are up above. So that was fairly successful from that standpoint. I think we've already talked about, we've got the low VOCs and the CO2 sensors, and then the cleaning side. Were you going to talk a little more about that?
I think that's one thing that the college utilized this building to really they transform the cleaning practices really across the campus. And
You know, maybe I could explain a little bit of my role in the process. I think I was introduced as one of the owners. I suppose I represent the owner. I feel much better being introduced perhaps as the end user. Remember, my title is Instructional Dean, and so I'm responsible for all aspects of instruction. And so I guess you need to know a little bit about community colleges if you don't know about community colleges. The core of our mission is education. That's all that we do, and we take that very seriously. We try and hire the best people that we can find that would be good instructors, and once we hire them, we invest heavily in them. We engage them in continuing education. They have to be aware of best practices in education. They have to be able to demonstrate commitment to their classes and demonstrate good learning taking place. And they really are a group of people then that become passionate for what they do. So if you can imagine this group of people being told that there's a possibility of having a new building in which they can teach, and all that they really needed to contribute is how much square footage do you require. It just didn't go over well, because these are the instructors that are working with our students. And I know some of this kind of sounds like cliche, but we're telling our students that they need to be thinking outside of the box. They need to be thinking at how they're going to be contributing back to their community. We need them to be critical thinkers, and these are some new concepts for them. How do you become a critical thinker? How do you, where do your opinions come from? So this is what we do, and this is what my instructors are engaged in. And a new building comes along, and they want to walk the talk. They need to contribute more to this process than just how many square feet do you need to teach in your classes. They wanted engagement. They really felt strongly that in order to have credibility in the classroom, they needed to be engaged in the planning of this building. How is this building interacting with the community? How does this building allow us to teach some of the concepts that we'll be teaching? One of the courses being taught in the building would be environmental science. How do you teach an environmental science class if you gave no consideration to the impact of the building that you're engaged in? And so this became a very interesting and involved conversation that we had with the administration. I really wasn't a decision maker, but I was very much invited to participate in representing faculty and students to those people that were making the decision. And so as this unfolded, we got involved in all of aspects of the building. We kind of got off the track here, but one of those things being, cleaning products. We were knowledgeable about that. We knew that the world is different than it was 30 years ago, and we needed to be open to new ideas and impacts. And so we brought this forward, and we tried to do our homework. And so when we presented information to the decision makers, we had our ducks in a row, and we could address some of this. We kind of know what we're talking about here. This is our area of specialty. We want to create a space that encourages healthy living because we're teaching health science classes. And so we had a very interesting dynamic that finally, over time, evolved into agreement that we need to do more than just design a building that could have been designed 30 years ago. We need to be sensitive to our students that are going to be in the building today and our students that are going to be in the building in the future. We need to be able to show that we do ourselves what we want our students to do, to plan for the future and take some risks and provide leadership for the community. And so that kind of led to some of my input into the process, and certainly represents the people that I was trying to represent as I presented information to the decision makers.
certainly. Just moving on. Really, the daylighting and the influence of the understanding of the energy model and energy usage quite early in the process was highly valuable. Not only the mechanical engineers had every bit the influence of the selection of the 5 different glazing types that Ken mentioned, as we do traditionally architecturally. the orientation of the skylight and the clear stories and the sizing of the windows and the fenestration on the north elevation versus the south was dictated by the electrical engineers every bit as much as the architects.
Well, it was interesting because we were, quite frankly, a little skeptical of how much light we were actually going to get from that clear story through the center of the building. Certainly onto the second floor classroom space, we were able to get that lighting in, but we were a little skeptical of just how much we were going to get into the first floor spaces. And the energy modeling and the daylight modeling that we did here at the lab certainly helped in that. That's set up so that we literally adjust lights on the perimeter space of the building versus the interior space at different levels, depending on that daylight contribution. On this project, we're 32% below energy code standards for a building of this type.
Did your discussion on sustainable cleaning practices impact your material selection?
It did. The question was, were the interior finishes impacted by the cleaning products and vice versa? Yes, the interior finishes. Christine's right behind you in the audience, the interior designer. I'm not much on finishes myself, but as far as expert, linoleum was selected. Our interior. Yeah, please help me out, Christine.
We considered annual maintenance costs for all the finishes that were there, so we went with as many modular products as we could and no finished products that we could. We tried to make sure that the furniture and the use of the space tied in with that. And we also very early on picked finishes and we provided all the light reflectance for the engineers for the modeling. So even though I didn't know exactly what finish, we had all the values for the finishes so that all of the models were correct too. Or at least close.
There you go. Thanks. I just stay out of these guys' way, really. I think one thing we wanted to mention on that previous slide, the reduce, reuse, recycle, and then the handout materials, it's really highlighted in there is the impact of the construction process. And
Yeah. If you noted back when at the original meeting when we had committed to work towards 50% recycled content, and that was a stretch for us. I mean, you think of the dumpsters that get hauled off a construction site, you think, wow, we need to cut half of that. That was a major commitment for us. We were thrilled to be able to grab that one more credit by bumping to 75%. And really what it came down to on that was a commitment from our team to do that, and then it was an education process. It was, and selecting what was possible for our particular area. We didn't recycle plastic or gypsum. I mean, there's facilities out there to do it, but not available in Twin Falls. We would have been dumpsterizing those particular materials and then trucking them halfway across the West, and we'd have been defeating the purpose. It burned a lot of diesel in order to do that. So we focused on what we were able to do in our area and had dumpsters out there for wood and for cardboard and for metals. I mean, we even had aluminum can barrels distributed around the jobs, and the guys got in the habit of, after you have your Coke at lunch, you crush the can and you toss it in the bin. That's just what you do on this job site. And that's how we were successful, was education and buy-in from team members. There was a buy-in from this team and from the management of Star Corporation, and then it needed to go to the particular supervisors that were on that job site to get their buy-in of it, and then they were tasked with delivering that same message to the tradesmen and to the subcontractors who were on the job site. And we took it on just like we would safety. I mean, during the weekly meetings, or at a couple times a week, we meet together and we talk about job progress, and we talk about quality, and we talk about safety, and we talked about recycling. We talked about as a reminder, what needs to go in this dumpster and what needs to go in this dumpster. And we had people assigned to keep track of that. And that's how we were successful, was education and buy-in.
So was there a return on recycled cardboard, 2 cents a pound or something like that? Or did you get, actually, was that
Yeah, not enough to retire on. There was no.
the concept?
There was a small cost return from, I think, cardboard. They just didn't charge us to put a dumpster on site. Same with wood. The recycling company took the wood and they would provide a dumpster for us in exchange for that. The metal is where we would have actually reaped a monetary benefit, and I don't know how much it was for the
We
entire
bail
job.
cardboard, but it was 2 cents a pound.
Oh, okay.
Just in terms of putting it and making it accessible to somebody else.
Sure.
So,
Okay. Yeah, it was minor, but the folks and it was a new concept in Twin Falls to when we called around to solicit companies to help us with this in the waste management and recycling business. You just don't see recycling bins on job sites in, well, many places, and it certainly hadn't hit in Twin Falls yet. And so it was a new concept. And we made sure everyone knew about it when they were bidding the project, that this was going to be an expectation. And we're not interested in whether you agree with it or not. This is what we're going to be doing. And I think by the end, guys had a good time with it. They would police each other, and had fun with it. But that's what it was: education and buy-in.
I think of the 27 or 30 subcontractors, subtrades on the project, there was the mechanical alone were the only company that worked on a lead project previously. So the education curve and the value of this project was really tremendous. And
Yes.
so.
On other projects, I've heard tricks of dumpster placement, like maybe putting the waste the furthest away. Did you develop any things like that, or they were all next to each other and people just did what they needed to do?
They were. We didn't have anything like that. They were all right next to each other behind the job, and we did have some separation inside the building, where when a trade would clean up, they'd have a bin where they could toss, metal stud scraps or things like that. But out back, they were all together. The dumpsters were. It was mostly just reminding everyone that it was important, and reminding them what they were a part of. This was going to be the first, because of their efforts, this would be the first LEED certified building in the Magic Valley, and that we needed their help, and we got it.
So are those waste separation techniques incorporated within the design, within the building?
Yeah, there's 3 recycling locations within the building as part of the LEED process. But as far as the construction waste management, it was entirely Starcorp that handled and dealt with that.
New concept for us, but once you learn how to do it and learn how to teach the people out there on the construction site, and I would consider doing it on other jobs. A wood frame structure, the guys have been taking firewood home for years, so I suppose that there's a recycling effort of sorts there. But on the right project, we would certainly consider doing this again, just because it was a good thing to do, not necessarily even if we were trying to earn a LEED credit. It makes sense with those recycling capabilities that we have in the Magic Valley.
Yeah. I think, Ken, anything to
Well,
highlight on water?
We are using a non-potable irrigation source, which was available on site, which was kind of nice to help cut down on the amount of use, and we did have the reduction in the irrigation. I guess the one of note is the 34% reduction of potable water use, which is good for the 2 points, and it was that was probably in part due to the use of low consumption urinals. We actually provided the school with a waterless right toward the beginning of the project, just so they could test it out. And we worked, as a matter of fact, had it designed in. When it went to the state for review, they said, "Yeah, we're not into waterless." So we went back to the 1/8 flush, which I think is being accepted as being successful. So that helped us with that reduction and still kept us underneath the requirement. So we just looked at all of the fixtures and tried to get them down. The building doesn't have a great deal of water use anyway, but yeah.
Just moving into a few recent, this is of probably a couple of weeks ago, shots of the building. And again, quite a dramatic entry, protected by the wind. This entry faces east. You see the vertical shading elements just above the main entry. That's a 2-story kind of entry space. There is a little bit of a departure from some of the buildings traditionally on campus. There's some outdoor balcony space outside some of the labs, simulation spaces that are on the 2nd floor. Again, just a little bit of the flavor of the building. Quite a departure for the college. There's significant student amenity space, gathering space, interaction space for the disciplines to interact. And again, lecture halls, and Ken's correct, that dry mechanical and those air handling units are directly overhead of the lecture halls, and they're very, very isolated, very nice.
Can you tell us something about the glass there that we see?
Yeah, this is a high performance glass. Zach, what was that? A Sungate 700? Solar Band 70 there? And then we were higher performance on the other corner, weren't we?
The east and west, we use the Solar Band 70 as kind of dark charcoal. And then in south and north facing, typical punched openings, we had just kind of low E, medium bronze. And then there was some north facing clear story elements that we used actually a clear as UV coatings for that, but it was clear.
Yeah. Yeah, so the much higher performance glass on the 2-story curtain wall element, a little lesser on the deeper punched smaller openings. And then like Zach mentioned on the clear story that we'll see an interior shot of here in a moment, still a low E insulated but untinted glass on that north facing curtain wall or slope glazing system up there. And again, you see that in this upper left-hand photo. Northern light, nice even northern light. Originally, initial concept was that was more of a roof monitor facing south to really grab it, and that early energy modeling benefit was spun the architects around and faced that to the north. So.
I'll just make a comment on, again, the educational aspects that are going on here. We're into our 4th year of student involvement in this building. I mean, we were so fortunate to have a design team that was willing over the course of this project to come to their classes and interact with students. Our students all had assigned research projects, and so they were researching various aspects of the building as the building was being built, and they could have interchange with the design team. And so we've really tried to make use of that component because it was there available to us. Now we have the building up, and as you can see these pictures here, there's all kinds of features to this building that the casual visitor would probably miss the point if they just walked through the building and say, well, this is interesting, I wonder why they did it like this. So we're in the process of having our biology students that are our majors preparing informational placards that will be installed throughout the building to explain what the visitor sees. And so we got a lot of mileage from that. As we tried to convince our administration to move in the direction that we wanted them to move, we kept bringing in these educational opportunities that our students would have and the community would get if we planned this right. And that was helpful for us. We were able to demonstrate that, you know, there's a lot to this. And a sticking point for the project from my perspective was when we finally got the decision makers to agree that, you know, you guys are on to something, that we do have some responsibility to address the issues that you're talking about, but we're going to do it ourselves, and we're not going to pay for a plaque dealing with the LEED certification plaque. And we kind of said, well, gosh, we really appreciate you've come this far, but the plaque really is a very powerful symbol to students that demonstrates that we're willing to be measured by a certification body. The analogy that I was using as I made this argument was, we require all of our students to become certified in the areas of their training to demonstrate that they have the training and they're willing to put themselves to a test to become certified. If you're familiar with education, a big topic in education today is outcomes assessment. You can't just say you're a teacher, you've got to be able to measure the learning. You can't just say you're a good teacher. If students aren't learning, that's the point. You've got to be able to measure that outcome. The LEED certification plaque says that we were willing to do what we said we were going to do and have someone verify that we accomplished our goal. And so we came all the way through that and finally got to that point where, yes, we're going to go for LEED certification, and the plaque is going to be in the building. And that's a big deal for us, because I think it is such a strong symbol to our students that we did it. We went the extra mile, and we can prove that we did what we said we were going to do. And so that will be a big day when that plaque is installed in the building.
Yeah, and really the biology faculty has taken this building on as its own almost, and seeking various grants down to VOC sniffers and everything. So they're really wanting to study and learn from this building and apply it throughout the campus. Just a few more shots here of the nature of some of the spaces, some of the more sophisticated spaces in the building. The dental lab and integration of new programs was really day one at the early pre-design meetings. They're just on the verge of starting a hygiene program in the dental lab as well. The radiation technology program, these are some of the simulation tables. There are 2 active x-rays in the building. And again, the placement of some of these spaces, so the rad tech can cross-train with the surge techs and take the C-arm into the OR and really capture what they're going to see in the real world, these students, one day. And then this is the LPN lab, I think, isn't it, upstairs?
It's the RN lab,
RN
registered
lab.
nursing.
Wherever the bones are.
You know, one of the things that we asked for in the building that you wouldn't see by looking at the pictures is flexibility in how the space gets used. We're pretty confident that this building is going to have different uses in 10 years from now. Technology is changing so fast in healthcare. We have to keep up with that, and we anticipate there are going to be programs that don't yet exist in this building. So we asked for things like plumbing in every classroom, even though it's not needed now. We've learned from the traditional campus that we have that to retrofit a building to do any kind of remodeling involving plumbing is almost impossible. So we want to anticipate that, hey, we're going to need that in the future. We don't exactly know what it is, but why don't you give us plumbing and drainage in every classroom so we could convert a classroom to a wet lab if we needed to. So those are the kinds of things you don't see from the pictures, but what we were asking for is we were anticipating what was going to be needed in the future.
And again, this is hot off the presses as of yesterday, the LEED scorecard ultimately achieving LEED Gold in the stretch and the strategy to have kind of that peer project manager really pushing us and challenging us. And then the biology faculty down in Twin Falls really pushing and challenging on their end to the administration to accomplish that. And again, if you recall back earlier, the water efficiency in the Twin Falls and the high mountain desert is a significant deal and a nice feature of the building to capture for really anywhere in southern Idaho. So the optimized energy performance, and again, STAR's efforts that Michael spoke of and all the trades efforts on the waste diversion we felt was significant, certainly.
But what was the non-potable water mitigation you were referring to? earlier?
Actually have a slough that runs past the property, and they pump out of that for their irrigation purposes. So it's not a potable source, so we're not using conditioned water, we're just using water from that slough.
The water from the slough comes from where? And do you have, it's constant? I mean,
Where does it come from?
It's
so to speak.
throughout the city of Twin Falls. There's an irrigation system fed from the canals ultimately, and it's the way that the farmers water their crops. It's the way that the
So there's more water in the slough in the irrigation season, probably.
That's correct. And,
Yes.
and about less than a mile from this site, half a mile from this site, it goes
right over
into
the edge of the canyon.
over the edge. So, it's kind of like use it now or forever hold your peace, so.
Generate power from the, okay.
Yeah, there you go.
And again, the final page and the summary of that, of the 46-point achievement.
What was your exemplary performance innovation?
The third,
You got an exemplary performance point. I'm just wondering what it was for.
that was for the Energy and Atmosphere Credit 1. The mechanical system ended up at 55.4%, better than energy codes. So
Okay.
yeah, it was exceeding that optimized energy performance. That's significant. And again, just a bit of a closing slide here with the, I guess, sharing some of the subtle techniques we were trying to push on the envelope or the balloon to challenge a traditional design methodology and kind of underlayment to the project that you really can't abandon, but moving towards a more integrated fashion and shifting that decision-making curve earlier in the project and really getting that early energy and early decision-making behind you. So you can focus on the act of construction and ultimately what, we're doing as designers is realizing that building. So we wanted to leave plenty of time for questions, hopefully, and
Well, I've got
love to
plenty, but
hear 'em.
I always save mine to the end.
Uh-oh.
So I'm going to try to swing this around so we can do a little better job of capturing audience questions. Are there questions for the design team?
I've got one. Can the builder quantify what he would consider to be the additional cost for doing a lead building as opposed to if he wasn't doing a lead building?
He chooses not to. I've been asked that question a number of times, and this is my answer. We weren't necessarily tasked with providing this is the jump from a baseline building to the building that's being requested. What we were given from the owner, which was ultimately DPW, was a construction budget and their expectations. When they had done their very initial programming, they expected 68,000 square feet. And then they left it really to the college and to the design team and their project management team to oversee that. But we needed to deliver that space, and we needed to deliver a building that would meet those requirements. And so actually during design, the building bumped about 4,000 square feet. And our contract actually was reduced a little bit. We didn't need quite all the money that the state had set aside in order to make the building just a little bit bigger and to meet the environmental requests of the college. So I don't. It would be something that we could go back and take a theoretical baseline building and put some cost to it, but they would be speculation at best. So we weren't tasked with that. Just we're tasked to stay within the budget and within the design criteria.
I've got a question from online from Andrew Stoner at Sarah Architects, I believe in Portland. And first and foremost, excellent graphic work on the project, he says.
Because about half of it's his.
So he asked a very good question. Although some of the architectural R&D in a project like this can be covered by the project fee, some of the learning process of developing the sustainable integrated design processes, et cetera, will inevitably land on the architecture firm to cover internally as sort of a development activity. In addition to having a green portfolio, a green project in the portfolio, what parts of the learning curve do you find that might translate into professional services in the future? Fees that you can charge in the future for activities?
Oh, boy. I would think the long-term relationship and maintenance of a building and post-occupancy maintenance of the structure certainly might be an avenue to maintain. I don't know. I guess thoughts as far as certainly kind of.
He asked the stumper for
I
you.
know. Darn guy.
How about the energy modeling and the time spent working with the lab on daylight modeling and things like that? Are those activities that you were able to cover within your project fee structure? Entirely, in part?
Yes. Yeah. We were within our contract with Star and certainly the benefit of the lab.
I think if there's one thing that we did learn that we probably didn't have covered, and that's that we did the filings for some of the incentives funds available through the power company. And one of the things we're going to change now in ours is that put in the front end of the specifications those required documents that we need from the contractor and all his subs in order to document that filing, because once those subcontractors leave the job, it's hard to capture them again to collect that information. So that's going to become another closeout item in our Division 1 portion of the specifications.
Do you have a feel for, has the incentive from Idaho Power been awarded to the project yet?
They've already received a little over $35,000 for lighting and lighting control. Because the mechanical system is somewhat unique and unlike anything they've seen before, we're still in that process on the balance of it, but it's going to be somewhere between $54,000 and $100,000.
And the uniqueness, it has to do with the fresh air and with the integration with the CO2 monitors
More of the water loop heat pumps.
and the what?
The water to water heat pumps that we're using in the building are a little bit different. They didn't quite have a slot for those.
Okay.
I was just curious in the early introduction of the energy modeling on the building, are there any other kind of anecdotal items that inform the architecture from the early energy modeling? Maybe besides, one was windows. Were there other issues that were caught early on to change the form of the building?
Yeah, the energy modeling certainly informed the entire, not just the windows, I guess, but the entire building skin certainly, and the mechanical engineers had as much influence over the amount and the placement of insulation and the whatnot.
Even to a certain extent, the layout of the building. One of the things that happened is like the computer labs were put on the north side, kind of some of the north facing, which really is helping us tremendously because it's allowing us to maintain our reset schedule on our air handling system longer into the day, because those rooms aren't contributing immediately to the requirement to lower the temperature in order to keep them cool. So there's some things like that I think can be thought of that really do impact the energy use on a building. It's dead simple to do if you think about it.
I did have one more question for Michael. Is there maybe beyond recycling? Is there any other thing that you're taking forward in your general practice delivering buildings that you may have learned from this project?
Yes, the main one is the delivery method. CTA and STAR and CSI have worked together on a number of projects together. I label this as our best. We came together well. We have a mutual respect for one another. We understand each other pretty well, and we're able to use that understanding of each other's strengths and this fully integrated team that we've talked about a few times to serve CSI and other owners. I think as Jason pointed out during the project, there were different times when we would each take the lead during meetings and during parts of the project. And so that we cemented and continue to learn about that relationship. And so that was a big one. We also, just the lead in general helped to refine our submittal process, I believe. It requires a very thorough job on submittals for all products that you're seeking any kind of lead point on. And so that's a great exercise in training, if you will, for ourselves to get better at and for subcontractors. I think that was that we would take those things away.
Mark, or maybe Ken knows too, with this building being drastically different than your legacy buildings, what sort of training or extra things did you have to provide for the maintenance staff and the people that are operating this building?
You know, I'm really not the person to ask. I know that they have done extensive training with the 3 custodians that we have assigned to the building. There's been a process there. There's been some frustration with some things that are working and that aren't working, but by and large, I see them every day, the custodians every day, and they're not complaining to me anyway. But I know it was new for them, and I believe one custodian chose not to go to the building just because that person was more comfortable with the traditional cleaning processes. But the ones that are there think everything's working well. They're pleased that what is being provided to them is meeting their needs.
What was he upset about?
I don't know about really upset. It just didn't want to go through the training process of learning how to use new compounds, cleaning compounds, just was more comfortable doing it the way he had always done it, and this building required that they step up and learn how to use the new cleaning products.
Give us an example. Okay.
I guess I've filled you in as best I could on it. I wish I had more for you.
Well,
And anything
just
on the-
continuing on the mechanical side of that, we did use a system that the college was fairly already intimate with, water-to-water heat pumps. They're already using that on their existing campus quite extensively, using the first go-around water, the 110 degrees. So from that standpoint, there were some changes that we made in order to be able to use the reject water on this facility, but by and large, we did a lot of things that were the same. Tried to correct some things that they had on some of the existing facilities that we tried to do a little bit better here. And and I've got to say that it's not without its problems even in this building from the standpoint of trying to get that system up and running properly. It is a fairly temperamental system. We're lucky to have the people that we have at CSI that do know the system and are willing and able to get involved with it.
How was the cooling accomplished?
It's used with the same. It's just the reversing valve on the water-to-water heat pumps. So we have what we call a split mode. At certain times of the year, we have to actually have a little bit of hot water and also some chill water so that we're cooling with the main system. But if there's some areas that really can't be quite cooled down because they still need the fresh air going to those facilities, for instance, we still need to provide a little bit of heat to those spaces. So between whenever our temperatures are below 55, we're in the heating mode. When we're between 55 and 70, we're in what we call the split mode. We go above 70, all of the heat pumps are then able to provide cooling through the air handling system.
Did you look at using that slew water at all in the summer?
We didn't. Part of the reasons why we probably couldn't do that is because of water resources requirements for that we were really kind of cut down on. They didn't want any thermal pollution going back in there. So that was, we looked at it, I think, long enough to determine that it was going to be a real fight in order to be able to do that.
Yeah, so we looked at the water rights issues with it and
Right.
the ability of water rights shares that the college had.
Yeah.
Are there any corrosion-related issues from the geothermal water, with the geothermal water?
Sure, and we had to make sure that we had the right materials and stuff that it's in the geothermal, that's exposed to that geothermal water in order to make sure that we
Is
didn't
that
have
part of
problems
the
with that.
temperamental issue that you were just referring to?
Temperamental issues is just trying to pull water out of a sump essentially, because like I say, we're just getting water that's coming down a large pipe that comes into a cistern that we're trying to draw out of and use that for the geothermal source, and then in just trying to maintain that the heat pumps so that they're operating properly. One thing about a heat pump, and I don't know how much anybody's really used them, but I kind of compare it to a big car. You turn it on and it likes to go down the road and kind of like this, but it doesn't like to stop very well and it doesn't like to start very well. So anytime that you have a situation where you go in a night setback, I mean, that system is going very well, and all of a sudden you say, now stop. It doesn't really care to do that. And so some of the controls have been a little bit temperamental in getting it so that we're able to do that, and then turn back on and provide a good ramp up so that you've got the heat that you need early in the morning has also been a little bit of a challenge. We're getting it. It's just been some controls issues that we've had to deal with.
Question?
I have a question for the engineer. It sounded like the heating and cooling distribution is by air, right?
That's correct.
But you don't have a underfloor distribution system, right?
No.
Did you look at that?
No. Well, we don't have any kind of, yeah.
Did that make sense? Did you look at that, or is it
From
just
a
not?
standpoint of like a radiant floor system
No,
or something like that?
underfloor air distribution.
Access floors.
Raised floor.
A raised
Raised floor, yeah.
We probably looked at it for a fairly short period of time. One of the things is because we were looking, especially at the very beginning of the building, we were looking at a lot more lab space, and we didn't think that was probably conducive at all to a raised floor system. So, and some of that lab space kind of went away after we really got into some of the programming. By that time, we probably already made some of the decisions on the types of systems that we were going to be using in the building. So, no, we considered it for as long as it took to say probably isn't the right system for this building.
So lab spaces because of sanitation issues?
Yeah,
I
I mean, anytime I think that you get any kind of a lab space and you got the possibilities of spilling things,
Okay.
a carpeted platform is probably not what you want in those spaces, yeah.
Right.
Or even a linoleum carpet, or linoleum platform where you've got crevices, yep.
How's the exterior glass cleaned? You had one great photograph. It looked like there were some sunshades and struts going out there.
There are, it really from the ground by lifts, college.
Okay.
Yeah. College will accomplish that, and there's access around the building to be able to accomplish it from lifts. We don't have any sort of tie-offs or anything like that.
The question for the college, do you think the next building built at CSI will follow the same process?
I do. They're talking about it. The college is committed to being a leader in the community. I think this building demonstrates that we made some right decisions. There's a lot of things going on around Twin Falls. When this building was being planned, there was a proposed coal-fired power plant for the area, so energy usage is an important topic in the community. We're always talking about water shortage, and so when we can say that our building uses is efficient use of water, I mean that says something to the community that we are sensitive to the impact of the college, and so I think so. I haven't heard anyone say that this was a mistake. I'm hearing just the opposite, that everybody's pretty proud of this at the college. I think that will carry over into the next building. But things all have to line up for those decisions to be made. So I would hope so, but I would be optimistic that would be the case.
I had just a kind of two-part question about some of the things that I have observed of CTA in particular, and you glossed over both of them. You mentioned them, but glossed over them. One was the data collection, and so you are already collecting real data and checking it against your models. So I'd like to hear some comments about the firm's commitment to that. And then the other was the seating reorganization that came about maybe after this project. So it's in some parts it's like Gunner's question to Star about what were some of the ripple effects of this type of a project in your firm.
Yeah, I guess I'll address those. So at the time these documents were being put together, I don't know if you're familiar with our offices or not, but we were about 60, 65 people at the time. Our architects were on one floor, engineers on another floor. We began to implement this Scrum meeting process where we huddle up in generally the architectural bin for a 15-minute interchange, pretty quick, energetic meetings. Who needs a breakout? Those would be scheduled, and those disciplines would get together that afternoon. After the project, it became quite evident, apparent, why aren't we sitting as architect, engineer, structural, mechanical, electrical architect, and production folks sitting together, and we made that move. I guess with that shuffle, the main project delivery teams shuffled. The discipline leaders or department leaders kind of stayed in a home base, so we all had a little security net and safety net to come back to, and if we needed that more senior resource, went along quite well. It's been with the slowdown in the economy, everybody's kind of gravitated back towards their disciplines, but as things pick back up and get rolling again, we're starting to mix folks around a bit more, and I sit right next to Ken and right next to mechanical, electrical engineer again now, and architectural production.
The energy collection, the energy data.
Well, I need to follow up on what Jason's comment was, because I'm the old guy in the office. And I come from that background where all the engineers are over here and the architects are over there and the interiors are over there. And so, going into this integrated design team was a bit of a different step for me. But having gone through the process on this one, and now very much in the middle of actually toward the end of the second project that's in the integrated design pod and using the scrums, we should have been doing this years ago.
There's actually multiple offices in CTA, and that's similar over to some of the offices beyond Boise where multiple disciplines exist, and they've gone to integrated seating, and it's been a nice cultural stir. Very cool.
As far as the data collection, we haven't gone and done post-occupancy interviews or anything like that with the users. Most of our feedback's been just when we're there touring the building, just engaging with the department heads and the various discipline heads that are there, and then from the facilities, and then Dr. Sudgen on the gentleman in charge of the facilities or the building. So,
however, we do have
that.
some electronic meters that one of the things that I think we were really concerned about is so we're doing this modeling. How's it really stack up? What we were very interested, because from the standpoint of if you're going to model it, you better make sure that it's accurate. And so we do have electric meters for the entire building, and then one for what we call the wet mechanical room, which is all the pumps, water source heat pumps, etc., and one for the dry mechanical room, which are the main air handlers. And then we were going to have one if we ever get photovoltaics, we would also do that. So we would have those 4 meters, which will at least tell part of the story. Obviously, we can't get down to the gnat's eyebrow on exactly where the power is being consumed, but at least it allows us to do that. And then we did take our modeling program and split it into those components. So when that data comes in from the college, we can, like I say, very quickly monitor that and see where we are going from the standpoint of energy use.
Is it possible to collect data on the lighting circuits, Ken?
Not at this point, no.
Okay.
mean, would there be something that one could put in terms of the gnat's eyebrow? Would it be possible to track hundreds of meters, so to speak? Would there be small, inexpensive, inline measuring devices you can put?
Excuse me, that's certainly possible. That wasn't part of the design at the time, but yeah, it's something that can be accomplished.
Do I see any other questions from the room? None? Any more online, do we know? Okay. Well, hopefully everyone's had the chance to get your evaluation form. Please do take the time to fill that out. Reminder to sign in. If you haven't done so, please do. On your way, if you need learning units, please give us your AIA number. Do we have certificates available yet for engineers? Doesn't look like it. So if you need an engineering certificate, please let us know and we'll get you one. You can email Gunnar, Gunnar G. And then again, for those online, we'll be sending out a test for your AIA CEUs soon. And then thank you all very much for coming and opening up the sort of inside story. Really appreciate to get the details at that level. Thanks to the funders, Better Bricks, Idaho Power, Avista, and Northwestern Energy, and thanks all for coming.